Hello everyone, so today we're going to go over the Unit 3 practice test. This video will cover the first 8 questions. Question number 1. We are given the graph of a function y equals f of x. We are to graph its inverse and determine whether or not it is also a function. So the original function has 4 points of note. First one is -5, 3, followed by -3, 5, and then the point 2, 4, and finally the point 4, 5. For the inverse, we simply take the x and y coordinates of each point and switch them. So we'll have the points 3, -5, followed by the point 5, -3, we'll also have the point 4, 2, and finally the point 5, 4. So now we can connect the points together to form a graph. And this is what the inverse will look like. Also of note is that if we were to draw the line y equals x, like so, then the function and its inverse will be mirror images of one another. As for whether or not the inverse is a function, we can see that the inverse does not pass the vertical line test. So for example, let's say x is equal to 4, and we can see that this vertical line passes through the inverse twice. Once here and once below the x-axis. So the inverse is not a function. Okay, let's find the domain and range of the inverse. We can see that the minimum x value is -3, and the maximum x value was 5. And as for the range, the minimum y value was -5, and the maximum y value was 4. Okay, so that's question number 1. Question number 2, we are to find the equation of the function y equals f of x, and then also find its inverse. So let's start with the function. You can see here it goes through the points. This is, of course, a parabola with the vertex of -3, -2. And we can also look at the shape of this parabola and notice that there's no vertical stretches. So simply put, the equation of the function y equals f of x would be y is equal to x plus 3 all squared minus 2. Okay. So what we can do is to write out the coordinates of all 5 of these points on the graph. So we also have -4, -1, as well as -2, -1, and also these 2 points have coordinates 5, 2, sorry, -5, 2, and also -1, 2. And to draw the inverse, we simply take all 5 of those points on the original parabola and switch the x and y coordinates. And if we add in the line y equals x, we can also see that it is in fact a reflection over that line. Okay, so the inverse will have points -3, -2, and then these 2 points here would be -1, -2, and -1, -4 respectively. And we also have the points 2, -1, and 2, -5. Okay. Now we're also asked to find the equation of the inverse. So we are going to switch the x and y of the original function and then solve for y. So we have x equals to y plus 3 all squared minus 2. So we can add 2 to both sides. And then we can take the square root of both sides. Notice here we have both the positive and negative square root of x plus 2. And then finally we subtract 3 from both sides. So y is going to be equal to -3 plus or minus, and then the square root of x plus 2. Okay, so the next step is to find a restriction on the original function that will make the graph of its inverse a function as well. So what we could do is we can restrict the domain so that it cuts the original parabola in half. So notice this line right here, this will be x is equal to -3. So we have a choice of either x is greater than or equal to -3 on the right, or x is less than or equal to -3 on the left. So both of those domain restrictions will cause the resultant inverse to be a function as well. Specifically, the x is greater than or equal to -3 will allow us to keep the top half of the resultant inverse, and x being less than or equal to -3 will allow us to keep the bottom half of the resultant inverse. So that is to say, this side, the right hand side, would have an inverse that is the top half of the square root function, and then the other restriction, x less than or equal to -3, will result in the inverse that's the bottom half of the square root function. Okay, so that is to say, again, this part corresponds to x being greater than or equal to -3, and this part corresponds to x being less than or equal to -3. Okay, so let's move on to question number 3. Okay, we simply have a linear equation here. We're looking for its inverse. So we switch the x and y. So we have x is equal to -6y minus 5. We can add 5 to both sides. And then we can divide both sides by -6. So we have y is equal to x plus 5 all over -6 as our inverse. Okay. Question number 4. So for this question, it says that we're given the function f of x equals 2x minus 4. We are to determine the inverse function, and then we substitute in 4, -2, and 8 respectively. So let's find the inverse function first. We have x is equal to 2y minus 4. So we have x plus 4 is equal to 2y. So we have y is equal to x plus 4 all over 2. Okay. That is to say, the inverse function is equal to 1/2 x plus 2. And we get that by dividing both the x and the 4 by 2 respectively. So now we can simply substitute in 4, -2, and 8 into the inverse function that we found. And so for example, in the first case we have f inverse of 4 is equal to 1/2 times 4 plus 2. So that of course is 2 plus 2, which is 4. Okay. So the first answer is going to be 4. Second answer, we're going to substitute in -2. -2 times 1/2 is -1. -1 plus 2 is 1. And finally, 8 times 1/2 is 4. 4 plus 2 gives us 6. Okay. So question number 5. So note that the first 4 questions were about inverse of functions. And now the next few questions will be about square root of functions and also the absolute value of functions as well. So question number 5. So it says to sketch the graph of the square root of a function f of x equals to x minus 5 all squared minus 2. So we can see that the graph was already drawn, so let's look at how it was produced. So what is to be considered are the y values of the original function. For example, at these 2 points, the y values of the original function were 0, and the square root of 0 is of course equal to 0. And also, when y is equal to 1 on the original function, we know that the square root of 1 is equal to 1. As such, those 4 points are our invariant points. Before and after the square root, the y values do not change, so the points don't change coordinates. So what other points can we use to draw this graph? Consider these 2 points here. When y was equal to 4, the square root of 4 is 2, so we have these 2 points here on the resultant graph. So we know that they're going to be on the square root of the f of x. So, and then all we need to do is draw a smooth curve connecting the 3 points on the left-hand side here, and then the 3 points on the right-hand side. Notice that this middle section here will have negative y values, so as such, those square roots will be undefined. So the square root function would not cannot be drawn there. So again, the additional points were produced using f of x equals to 4, because that's a perfect square, or 9 if it was available, since the square root of f of x would then be 2 or 3 respectively. Okay. So let's move on to question number 6. Oh, actually, there's still the domain and range, right? Sorry about that. So the domain and range. For this particular question, we can actually find the domain and range with a little bit more accuracy. So consider the following. We know that f of x is equal to x minus 5 squared minus 2. So if we let f of x equal to 0, we can find the coordinates of the x-intercepts. Okay, so we have 2 on the left-hand side, x minus 5 all squared, square root of both sides, so this will be positive or negative the square root of 2, and that's going to be equal to x minus 5. So x is going to be equal to 5 plus or minus root 2. Okay. So the point on the left here, we now know the precise coordinates. This was going to be 5 minus root 2, comma 0. And the point on the right, this will be 5 plus the square root of 2, comma 0. Okay. As such, the domain of the square root of f of x will be from negative infinity to 5 minus root 2, and then square brackets, and also 5 plus root 2 with square brackets, all the way to infinity. The range will simply be y is greater than or equal to 0. Okay, since this function will continue on upwards. Okay, let's move on to number 6. See here, it says a transformation image of the graph of y equals f of x, and then we're given y minus 2, and then 1/4 the square root of the absolute value of f of negative 2x, and then minus 3 still underneath the square root sign. Says the point 6, negative 7 lies on the graph of y equals f of x, and then we're looking for the corresponding point on the image graph. Okay. So what we know is that for this function, f of 6 is equal to negative 7. So we want negative 2x to be equal to 6. As such, x is going to be equal to negative 3. Okay. So what happens then? Well, then we have y minus 2 is equal to 1/4 the absolute value of f of negative 2 times negative 3, if we let x equals to negative 3 here. And then all of this will be minus 3, and that's all going to be underneath a square root sign. So we know that negative 2 times negative 3 here is going to give us 6. So let's simplify that term. And the only point that we know about is that the f of 6 is equal to negative 7. So in the next step, we can substitute negative 7 into the expression. So we have absolute value of negative 7 minus 3, all underneath the square root sign. of course, the absolute value of a negative 7 is just 7. So this would be y minus 2 is equal to 1/4, and then 7 minus 3, all underneath a square root sign. So from there, 7 minus 3 is 4. And we know that the square root of 4 is 2. Okay, 2 times 1/4 is 1/2, so y is going to be equal to 1/2 plus 2, so 2.5. So that is to say, we know that if x is equal to -3, then y is going to be equal to 2.5. And that will be the corresponding point to 6, -7 on the original y equals f of x. So we can write our answer as a prime if we treat the original point as a, has coordinates -3 and then 2.5. Let's move on to number 7. Right, so we are given a linear function and we are asked to find the square root, or sketch the graph of its square root. So just like before, we're looking at the point where y equals 0, and this was -1, 0. And we're also looking at the point where y equals 1, and this was -3, 1. And these two would be our invariant points, because the square root of 0 and 1 are 0 and 1 respectively. Okay. Notice that in this first part of the graph, when the y values of the original function were between 0 and 1, the square root of those values will always be greater than the original values, so the curve in red is higher or above the original line. Once we are past the point -3, 1, however, the y values are then greater than 1 in the original function. As such, their square roots will be less than that function. And we can see that the red curve is below the original line. Okay, so the domain of this, we can see that y is less than or equal to -1, and sorry, x is less than or equal to -1. The range y is greater than or equal to 0. Okay, that's it. Number 8. So the original function was a upside down parabola. In order to find out what the sketch of the graph y equals to the square root of the absolute value of f of x, we need to apply the transformation from the inside going outwards. So first, we need to find out the absolute value of f of x, and that is the graph in red. So simply, this part of the graph is the same as the original function has y value greater than 0. This part of the graph gets reflected as all the negative values will become the positive equivalent. Likewise on the right hand side as well. So that's how we end up with the red graph of y equals to the absolute value of f of x. From there, we simply take the square root of that function. Notice, for example, the square root of, sorry about that, 0 is still 0, so we have our invariant points of 0, 0, and 4, 0. And also there are a couple of invariant points here when y is equal to 1. So again, that is to say, we have invariant points where y was equal to 0 or 1, and 1. So we have those 4 invariant points. Okay. And here we also have to point to 4 on the absolute value function. And of course, the square root of 4 is 2, so that's why this point is included. Okay. And all we did from there was connect the points with a smooth curve, and also following the rule where if the original function was between 0 and 1, the y values were between 0 and 1, then the square root will be greater. And if the y values were greater than 1 on the original function, then the square root will be less. Okay. So now the domain and range of the blue graph, the square root of the absolute value of f of x, the domain will be all real numbers, and the range simply y is greater than or equal to 0. Okay, so that's the first 8 questions. That's it for now, so thank you for listening.